I'll give you a basic overview of what exactly Apache Pig is all about, and then we can do one exercise in writing the Pig script. So, what is Apache Pig? Apache Pig is a high-level language which is an abstract layer on top of MapReduce. Internally, this Apache Pig is converted to the MapReduce program. It was introduced by Yahoo Labs in 2006 and was officially announced as Apache product after it was opted by the Apache Software Foundation. The Pig data flow has multiple transformations, so we call Pig as a transformation or a data flow language. Now, the MapReduce expects programming language skills for writing the business logic, but Pig does not require Java skills, as we are writing the whole logic making use of built-in transformations. So Pig has built-in transformations which are also called as Pig operators. If you do any change in MapReduce, you follow a certain process to accommodate the same change on top of data, like compiling, executing, packing the jar, deploying in cluster environment, and so on. Whereas in Pig, simple scripting is only used without the above transactional process. Some of the key terms in Pig are very important. For example, you have a term called relation. Now, they are also referred by name or alias. For example, the name or the alias of the relation in the following script: A equals load the file called, let us say, student.txt file using Pig storage, right? And in the brackets you give the delimiters, whether it's a tab or a comma or a semicolon and so on, as then you say, for example, name is character array, age is integer, and then you have, let's say, GPA is defined the data type as float, right? In this example, A is the relation, right? So relations are very important. Now, in data flow language like Pig, each processing step results in a new dataset or relation. In this particular example, now after you load the dataset called student.txt, it is resulting in a further dataset. But the relation is not a variable, right? So in addition to relation, there are fields. In addition to relation, we have fields such as name, age, and GPA in the above example. These have got different data types. Now, relation and fields must start with alphabet, and they are case sensitive. Keywords, for example, keyword like load is not case sensitive. You can write it in these small letters too. Now, Pig storage is a built-in function. Okay. For example, you can load your data with the delimiters separated by tabs or comma or full stop or hash or any other kind of delimiters. Now, in the example above, the data types that we are using are character array, which is pretty much like string, and then you have int, which is integer, and the third GPA, which is called the float. Okay, now the positional notation, let us draw, for example, a particular table. In this, let me draw a particular table with 4 columns and about 5 rows. Right. Here, I could write the first field, second field, and the third field. The data types that we have used for the first one is character array, the second one is int, and the third one is a float. The positional notation can be represented as $0, $1, and $2. We have names, possible names, which are name itself, age, and GPA. The field value could be John, who is 18 years of age and who has got a GPA of 4.0. This is how we can try to represent for the pig relations and the particular data types and the fields also. Let us see the modes of execution. The first and foremost is the local mode. The syntax is always dollar followed by pig minus x and local. The second one is the map reduce mode or the HDFS mode, where the syntax is simply pig, or you could also write it as dollar pig minus x and map red. However, it seems that pig itself is sufficient. These are the two modes of pig execution. There are flavors of pig execution also. The first one is the grunt shell. So when you enter the pig minus x local or the pig, it takes you to the grunt shell, which is default mode of execution with an interactive shell. So I would say this is the default mode of execution with an interactive shell. What do we mean by interactive shell? The output is generated whether it is a success or a failure. The second flavor of pig execution is script shell. Instead of giving commands one after the other in grunt shell, there is a provision for giving all commands in a single file, which ends with .pig extension. All commands in a single file with a .pig extension. For example, you have sample.pig or you have group script.pig. The third one is the embedded mode or the flavor of execution. Right. You can also write your custom user-defined functions too. Okay. Now, let us look at any example in the actual pig screen itself. So let me take you to the pig screen itself. So we have accessed this particular directory called batch25 from the root. Inside there are no files absolutely. Good. Let us make one file. Nano, let's say it as inputdata.txt. It takes us to a particular screen where you can enter your own data. So I'm writing the ID, name, and the salary separated by a tab. So let's say John, 52,000, Max, 65,000, 102, Mark, 70,000, 103, Twain, 90,000. Right. Let me save this data. So I press Ctrl X Y for yes for saving, and then I press enter, and we are back to our own terminal. Now, in order to work from the grunt shell, it would be easier for us to open a new terminal. So the shortcut for that is Control Alt T. Here I would enter the root mode, right, and then I would enter our batch 25, and then I would say pig -x local. So this particular terminal should take me to the grunt mode. Here I would enter the relation A, for example, equals, let me load the data, load input data.txt using the built-in function called pig storage, which is separated by a tab. So let me do it this way, right? And using pig storage separated by tab delimiter as, say, ID, which is integer, followed by name, which is character array, and then we have got the salary, which is integer. This ends, please remember, with a semicolon. If there are no errors, it would take me to the next grunt shell. Here, let me give a new relation, which is defined by b equals for each a generate $1. $1 is the second column. If I say, using one of the pig operators, describe b, it would actually tell me that it is going to print the second column, which is name, which has a data type of character array. Now, there are two ways of looking at the output. One is the dump way. Let's say I press dump, right, and it shows me the output right on the console itself. There is a second way of doing it. Okay, let's do this first. Dump B. So you would observe that it is running a MapReduce program in the backend. If it is a success, it will directly tell us or show us the output on the screen. Excellent. So we have the second column, John, Max, Mark and Twain, represented here. If you would like to store it in a particular directory, then you would say store B into, then you give the particular directory name, for example, pig out. Please remember, this pig out is a directory and not a file, right? So let us see. If you access this particular directory, since it's a direct output of the second column, it is going to be a mapper file. Okay, so it is a success. Let us go back to our other terminal and look at what are the directories that are found. So you can look at the pig out directory here. If you would like to see what is inside the pig out, then ls, you have the directory called pig out, and there is a mapper file here, part M followed by 5 zeros. If you'd like to see the output here, let us look at it. Cat pig out, and then you have your part. You can press a tab here and it will give you the same output which we have seen earlier, right? I hope you got this example. If you're interested in online classes, you can contact me at the information given below this video.